Let's see how we are going to integrate 1 divided by x square plus a square with respect to x. So basically here we will apply the substitution method. We will develop a FTP fingertip formula for the end result of this integral. We know the basic of trigonometry, 1 plus tan square theta is sec square theta. That is something basic in trigonometry. Got it? For integrating this integral, the integrand is 1 by x square plus a square. So we'll have a substitution. Let x is equal to a tan theta. Okay, let x is equal to a tan theta. We are taking a substitution. Let x is equal to a tan theta. Let there be some angle theta, arbitrary angle theta, where x is such that x is equal to a tan theta. Now if you differentiate both sides, so the derivative of x is 1, and with respect to x we will write dx. A will be a, the derivative of tan theta is sec square theta, and then we will write d theta. So this is the differential form. Dx is equal to what? A sec square theta d theta. Got it? No, derivative of tan theta is how much? Sec square theta. So if you put these values in this integral, so instead of dx we can write a sec square theta d theta divided by x square. So x is a tan theta square plus a square. Got it? So I will get this integral as a sec square theta d theta divided by, I can take a square common, and what is left is tan square theta plus 1. Now this a will cancel away, and a being a constant can be taken out of the integral. Now what is tan square theta plus 1? Sec square theta. So I'll get sec square theta by sec square theta d theta. So see, sec square will get cancelled away. You will get what? 1 by a d theta, and integral d theta will be simply theta. Okay? And plus c. That is a constant of integration. Indefinite integral. If you're putting the limits, there is no need for c. Now we can't leave answer in theta because theta is the intermediate adjacent. We have taken x theta. X is equal to a tan theta. So tan theta would be x by a. So therefore theta will be what? Tan inverse x by a. Okay. So it will be 1 by a tan inverse x by a plus c. That is the final answer. So we got, and remember for the direct application in the problem, whenever we have the integral dx divided by x square plus a square, it will be 1 by a tan inverse x by a plus c. Got it?